So this is Module 22, which is the last of our three-part series on learning, which is the effects of biology and cognition, learning by observation. So we've already talked about classical conditioning and operant conditioning, but there was a third way that was talked about, and that was cognitive conditioning. So some of the factors that affect our learning are our biological influences. So we know that some people have genetic predispositions to be better or worse learners than others, are the way that we respond to unconditioned responses and our adaptive responses. We also know that there are psychological influences such as our mental states, previous experiences, the predictability of associations, our ability to generalize and discriminate. And there are also sociocultural influences like culturally learned preferences and motivation affected by the presence of others. So what role does biology play in conditioning? So in classical conditioning, one researcher found that it was easier to learn associations that make sense for survival. Sorry, we're just having some technical difficulties here. So kind of fear of snakes, etc. So things that make sense for us are easier to learn, which makes sense. So food aversions can be acquired even if the nausea, the unconditioned response, does not immediately follow the neutral stimuli. So when recurring food aversions during pregnancy or illness, the body associates nausea with whatever food was eaten. I know that I have felt nauseous, and even though it's been several hours later, you kind of feel the food that kind of caused the nausea, and therefore you're avoiding the food even if it didn't immediately precede. One study found that males were more likely to see a woman as more attractive if the picture had a red border. And I have to say, even myself, just looking at these two pictures, I think that the one on the bottom is more pleasant because of the red border, because red kind of elicits feelings of warmth and love. And a quail can have a sexual response linked to a fake quail more readily and strongly than to a red light. And so even we compare different stimuli, the fact that one stimuli looks like a quail and the other one doesn't makes it a stronger one. So the role of operant conditioning in biology. Can a monkey be trained to peck with its nose? No, but a pigeon can. Can a pigeon be trained to dive underwater? No, but a dolphin can. Operant conditioning encounters biological tendencies and limits that are difficult to override, and so there are certain things that we can and cannot do due to our biology. So we can most easily train a dog to do basic things that are based on its natural tendencies, like detecting sights, climbing and balancing. Don't think that we can necessarily teach a dog to put on clothes. So the cognitive processing processes that are involved in classical conditioning, so when the dog salivates at the bell, it may be due to cognition, so learning to predict, even expect the food. So conditioned responses can alter attitudes even when we know the change is caused by conditioning. However, knowing that our reactions are caused by conditioning gives us an option of mentally breaking the association down. For example, deciding that nausea associated with food aversion was actually caused by an illness. So, in the example where I gave you where I felt nauseous and I associated with the food, if I then found out that my son had a virus and that's what caused nausea in our family, therefore I may not have the aversion to the food. So I think this is kind of a critique of some of the behaviorists, because we do have used mental processes in these. So higher order conditioning involves some cognition. For example, the name of a food may trigger salivation, and so that involves cognitive processes as well. So if I tell you, chocolate layer cake with chocolate fudge sauce smothered in ice cream and whipped cream, I mean, just that, you can imagine a picture, and so that's not a physical stimulus, but a cognitive one. In operant conditioning, fixed interval reinforcement, animals do more target behaviors and responses around the time that the reward is more likely, so they're expecting the reward. And expectation as a cognitive skill is even more evident in the ability of humans to respond to delayed reinforcement, such as a paycheck. And in terms of higher order conditioning, we can be enabled with cognition because seeing something such as money as a reward because of its indirect value. And humans can also set behavioral goals for themselves and others and plan their own reinforcement. So we can ourselves decide what's reinforcing for us and plan accordingly. So latent learning. Rats appear to form cognitive maps as well. They can learn a maze just by wandering with no cheese to reinforce their learning, so they can kind of figure out the maze just by developing a mental map. And so evidence of these maps is revealed once the cheese is placed somewhere in the maze, and only after a few trials are these rats quickly able to catch up in maze solving to rats who were rewarded with cheese all along, because they have this mental map in their head which is blocking them from getting the cheese. So latent learning refers to skills or knowledge that's gained from experience but not apparent in behavior until rewards are given. So you wouldn't have known necessarily that the rat had formed this map, but when we was compared to rats who didn't have the practice and it took them longer, it shows that there's something interfering, which is this mental map. So our favorite golfer, Tiger Woods, on the right, people may have mixed feelings, but intrinsic motivation refers to the desire to perform behavior well for its own sake. So some of you, are here because your parents pressured you, but a lot of you are here because you are intrinsically motivated to do well and you are proud of yourself when you do well. And so the reward is internalized as a feeling of satisfaction. Extrinsic motivation refers to doing a behavior to receive rewards from others, and so that's kind of, our direct operant, our reward and punishment. So intrinsic motivation can sometimes be reduced by external rewards and can be prevented by using continuous reinforcement. And one principle for maintaining behavior is to use as few rewards as possible and fade the rewards over time. So, you don't want your kid to perform only because you're giving them a cookie or money or whatever else. You want them to derive internal or intrinsic satisfaction, and therefore that becomes rewarding in and of itself. What might happen if we begin to reward behavior someone was already doing and enjoying? Well, it might stop them from intrinsically wanting to do it. It might not make them behave as well. We also learn by observation. So can we, like the rats exploring the maze with no reward, learn new behaviors or skills without direct experience of conditioning? Yes, and we do that by observational learning, which is watching what happens when other people do a behavior and learning from their experience. We do a lot of this in our lives. So we have to be able to mirror, which is picture ourselves doing the same action, and notice the consequences and the behaviors that the person is engaging in. So modeling is the behavior of others that serves as a model. So we look up to people, our brothers and sisters, for example, and we see what they do, and then depending on whether they were reinforced or punished for their behavior, we then, we engage in similar behavior. Vicarious conditioning is we experience indirectly through others vicarious reinforcement and punishment, which means our choices are affected because we see the consequences to others. And this is how our criminal justice system is based, because we're supposed to see the consequences to other people. And therefore, therefore we increase and decrease our behaviors appropriately. You may be summarizing Albert Bandura's Bobo doll experiment. It's a very kind of seminal, important experiment. So kids saw adults punching an inflated doll known as the Bobo doll while narrating their the adult was narrating their aggressive behavior, saying things like kick him, punch him, hit him. And these kids were then put in a toy-deprived situation, and they acted out the same behaviors they had seen with the Bobo doll. So you can see the adult is punching, hitting, kicking the doll, and then when the kids were put in the same situation, the kids then mimicked the behavior of the adult just by watching. So it's a very powerful experiment, and it shows the effects of modeling. So here is the effect of mirroring in the brain. So when we watch others doing or feeling something, we have neurons that fire in patterns that would be firing as if we ourselves were doing the action or feeling it ourselves. So for example, on the bottom left, we have pain. So if we see somebody getting hurt, the same areas in our brain light up. And then also the areas responding to empathy, where we feel the emotions that other people do. So it's kind of, we have these mirror neurons in our brain. So from mirroring to imitation. So we are prone to spontaneously imitate behaviors and emotions. This is called emotional contagion. So if we see other people feeling happy, we're more prone to feel happy. If we see others feeling sad, we're more prone to feel sad. So this includes over-imitation, so copying adult behaviors that have no function or reward. So children with autism are less likely to cognitively mirror and less likely to follow someone else's gaze than a typical toddler below. And so you'll see that the toddler is looking at the object because the woman is looking at the object. But then when we have mirroring plus vicarious reinforcement, we are able then to see the consequences of the behavior, and we're more likely to do it. For example, monkey A saw monkey B getting a banana after pressing 4 symbols. Monkey A then pressed the same 4 symbols, even though the symbols were in different locations on monkey A's screen, because monkey A saw that monkey B was getting reinforced for those. So what are some of the pro-social effects of observational learning? So these are things that we do kind of to help others, which benefit and contribute to our values groups and moral codes and norms. And so we try to teach our children by modeling good behavior, appropriate interactions, politeness, things like that. And so if we model this behavior, then our children are more apt to do it. But there are also antisocial effects of observational learning. So that kids learn, behaviors by watching adults do bad behaviors. Like the little girl on the left is spanking her doll because she was spanked by her parents, and so she's modeling that behavior. And we know that kids who witness violence in their homes but are not physically harm themselves may hate violence, but then they still become more violent than the average child. And maybe this is a result of the Bobo doll effect. So under stress, we do what's been modeled for us. And we see a lot of models of violence in the media, and there's like a whole controversy about, do kids want, mirror what they see on TV? A lot of people say yes, and a lot of people say no, but research does show that viewing media violence leads to increased aggression and reduced prosocial behavior, such as helping an injured person. And this violence viewing effect might be explained by imitation, but also desensitization towards pain in other people. And now with, the avatars and the more realistic depictions of violence in video games, it's kind of unclear the effect that this is having on